Hello students, today we are going to discuss chapter 1 real numbers. In this chapter we are going to discuss about prime factorization of numbers. So our first topic will be prime factorization. Then we will find HCF and LCM of given numbers. This will be our second topic. And then in this chapter we will study about irrational numbers, which you have studied before also, and then we will study about terminating and non-terminating decimal expansion. So these are few topics which we are going to discuss in this chapter. So today we are going to discuss prime factorization, HCF and finding LCM. So in this video you will learn how to find prime factors of a given number and how we can find HCF and LCM of two given numbers. So let's begin. So first of all we have a theorem named Fundamental Theorem of Arithmetic. Now you don't have to remember any proof of it. You have to just remember the statement of this theorem and you have to apply it in solving various sums of the exercise. So what does this say? Fundamental Theorem of Arithmetic says every composite number can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factors occur. First of all, we should know what is a composite number. Any number which has more than two factors is a composite number. Generally, we have two types of numbers. One type of numbers are prime numbers and other are composite numbers. So what are prime numbers? Prime numbers are numbers which have only two factors, 1 and the number itself. And all other numbers which are not prime, they are called composite numbers. They have more than two factors. 1 is also a factor for them. The number itself will be also a factor, but they have some more factors also other than 1 and itself. So those type of numbers are called composite numbers. Now let us take example of some composite number. For example, we take 8. Now how we can write 8 as product of its primes? We know 8 appears on 2's table. We can write 8 as 2 into 2 into 2. So 2 is a prime number. So we can write 8 as product of prime number, that is 2. And this can further be written as 2 raised to power 3, as 2 is appearing 3 times here. So 8 can be written as 2 into 2 into 2 or 2 raised to power 3. Let's take another example. For example, 15. We can write 15 as 3 into 5. So 15 can also be written as product of prime numbers, that is 3 and 5. Here we see 2, 3 and 5. These are prime numbers. Now what does this theorem says? That every composite number can be expressed as product of primes. Here we have expressed composite number 8 and 15 as product of prime numbers. So this theorem also says that every composite number can be written in the form of product of prime factors. And this factorization is unique. Now what does this mean? That this factorization is going to be unique. Now I can either write 15 as 3 into 5 or I can also write 5 into 3. Now I have just changed the order of the prime numbers. Here 3 is written first, then 5 is written. Here 5 is written first and then 3 is written. So this theorem also says the same thing, that this factorization is unique. Now this and this both are same. There is nothing different in these two factorization. Only the order in which the prime factors are appearing, that is different. So it doesn't matter which number, which prime number we write first, but this theorem says that every composite number we take, it can be written as product of prime factors, and this factorization is unique Only we can just change the order of prime numbers as we have done in case of 15. So you need to remember the statement of the theorem. Now we are going to apply this in solving various sums of the exercise. Now let's start with exercise 1.2, first question. I am doing its second part. Here what we have to do, we have to express this number 156 as product of prime factors. Now for simpler numbers we can just think on which table this number appears, and we can write its prime factorization as we have done in the case of 8 and 15. But 156 is a big number, so what we are supposed to do? First we will make its prime factors. We will think of some prime number which will be its factor. Now we know that 156 is an even number. So last digit is 6. It's even number. So it is going to appear in 2's table. So we will divide it with 2. Then we can check that when we divide 156 by 2, it will come on 78. Similarly, we can further think 78 is a factor of 2. 2 is a factor of 78 because it has 8 at the last. It is an even number. So if we divide 78 with 2, we will get 39. 2 39s are 78. Then 39, it's an odd number. It doesn't come on 2's table. Then we have to think of some other prime number which is its factor. Now we know it will come on 3's table. At 3 13s are. Then we have 13. 13 is a prime number. We should know which prime numbers are there. So it will come on 13's table. 13 1s are. So how we can write 156? We can write it as product of these prime factors. So we can write 156 equals to, these all numbers are prime. We can multiply them and write. So we can write 2 into 2 into 3 into 13. This is the prime factorization of 156. If we multiply all these numbers, we'll get back 156. So I hope you are understanding how we can express any number as product of its prime factors. So one thing we have to ensure that the numbers which we are using here for division, all these numbers must be prime. Like 156 will appear on 4's table also, but we can't take 4 here because 4 is a composite number. Only prime numbers we have to use this side, right? Now let's take another example. In this we have to make prime factors of 3825. So let's write this number first. Since we can see that its last digit is 5, so 5 will be one of its factors. So we can start dividing it with 5. So when we divide it with 5, we get 5 7s are 35, and then it will go on 6 and 5. So we will be getting 765. Next again we can divide on 5 and we will be getting 153. Now this number will be divisible by 3. So we can divide on 3. It will come 3 into 51. So when we divide it with 3, we get 51. Now 51, it will again divisible by 3. So we will be getting 17. 3 17s are 51. Since 17 we know it's a prime number, we should remember the prime numbers. So it will come on 17's table. So we will write 17 1s are. So all these prime numbers are factors of 3825. So it can be written as 3825 equals to 5 multiply 5 multiply 3 multiply 3 multiply 17. So this is the prime factorization of 3825. Now next we will find LCM and HCF of 26 and 91. We have learned how to find prime factors of given number in the previous sums. Now we will be using it to find LCM and HCF of these two numbers. So first of all, we will find prime factors of 26 and 91. Let's write their prime factors here. First, we will find prime factors of 26. It will be divisible by 2 and we will be getting 13. 2 13s are 26. Since we know 13 is a prime number, so it will be divisible by 13 only. It will appear on 13's table only. Next, we will find prime factors of 91. 91 is divisible by 7. We can start checking on different prime numbers and we will see that it is divisible by 7. And when we divide it with 7, it comes on 7 into 13. 7 13s are 91. Now 13 will come on 13's table. So we have got prime factorization of 26 and 91. So first we will find prime factors of these two numbers separately and then we will find their LCM and HCF. So let us write the prime factorization. 26 can be written as 2 into 13 and 91 can be written as 7 into 13. Now how we can find HCF and LCM? First of all, we will find the common factors. We will see which is a common factor of both these numbers. We can see that 13 is appearing in both prime factorization. So 13 is a common prime factor of these two numbers. So we can circle the common prime factor. So whatever we get common factor, that is HCF of given numbers. Sometimes we may have more than one common factors, then we can include both. In this case, we have just 13 as a common factor. So we can write HCF is 13. So you have to circle the common factor and that will be HCF. And now we will find their LCM. Since HCF is, its full form is highest common factor. So we have chosen common factors and we have written. LCM means least common multiple. So in this we will include all the prime numbers. So how we can write LCM? In case of finding LCM, we will write all the prime numbers including common factor, but we will write lowest power of common factors. So first we will write 2 into 7 into 13. Whatever numbers we have not circled, we will write them in LCM, and whatever we have circled, whatever is common, that we will write one time, and whatever is left, that will be also coming. So in case of LCM, we will write all the prime factors with their lowest possible power. Wherever we are having common factors, we will write them only once. So we can see that 2 is appearing only one time, 7 is appearing one time, 13 is appearing once in both. So we will write 13 also one time. By multiplying all these, we will be getting LCM. So if we multiply them, we will get the least common multiple, which is 182. So this is how we can find LCM and HCF of given numbers. Now we can also verify a formula that LCM into HCF equals to product of two numbers. This is a formula which we can verify whenever we find LCM and HCF of two numbers. We can apply this in case of two numbers. Since we have seen in the previous example, we have taken two numbers, that is 26 and 91. So we can put values in this formula to verify whether we are getting both sides equal or not. So first of all, we can put value in left hand side. Left hand side is LCM into HCF. Now what LCM we have found? We have found 182 as LCM and HCF was 13 in the previous example. We can write from here, and in right hand side we need to put product of two numbers, means we need to multiply the two numbers. The given two numbers were 26 into 91. Now we can find their product and we can check whether we are getting the two products same or not. We must get them same. So let's multiply them and then we will write our answer. On multiplying these numbers, we are getting 2366 as the product. So we can see here that LCM into HCF of two numbers is equal to the product of two numbers. So this formula is verified. So sometimes in some questions you may be asked to verify this formula. So we can verify it like this. So first we need to find LCM and HCF of the two numbers, and then we can verify this formula by putting values in this. Now here is another example. Here we have numbers 336 and 54. Its prime factorization I have already written. Now we need to find their HCF and LCM. Now 336 has prime factors 2, 3 and 7. 2 is appearing 4 times, 3 and 7 one time, and 54 has prime factors 2 and 3. So we can write their prime factorization like this. Now we will find their HCF and LCM. So first of all we will find HCF. We will find out the common prime factors. We can see here 2 is common in both, then 3 is common in both. These are only two numbers which are appearing in both. So we can write the common numbers, common factors 2 and 3. When we are finding HCF, we have to write the smallest power of the common number. Now we can see 2 is appearing only one time in this. Here it is appearing 4 times, but it is appearing only once in case of 54. So we will write 2 once. Similarly, 3 is appearing only one time here, so we will write 3 one time. So HCF is 2 3s are 6. Now to find LCM, we have to write all the prime factors with their highest power. Now which prime factors are there? We can see numbers 2, 3 and 7. Now 2 is appearing maximum 4 times in this number. So we will write 2 power 4. 3 is appearing maximum 3 times in this number. So we will write 3 power 3. While 7 is appearing only one time in this number. So we will write 7 power 1. So when we are finding LCM, we have to write all the prime factors, all the prime numbers, and we have to mention their highest power. So when we multiply all these factors, we will be getting LCM of these numbers as 3024. You can multiply and check. So this is how we can find LCM and HCF, and further we can verify the formula also, that LCM into HCF equals to product of the two numbers, that is 336 and 54. So this I am leaving for you to try yourself. Now let's take another example. Here we are having three numbers whose LCM and HCF we have to find. So first of all we will find prime factors of these three numbers, 12, 15 and 21. We know 12 comes on 2's table, so we can start with 2 and its prime factors will be 2, 2, 3. Similarly, we can find prime factorization of 15. It appears on 3's table, so 3 5s are 15, and 21, it will come on 3's table, 3 7s are 21. We can write their prime factors like this: 2 into 2 into 3. For 15 we can write 3 into 5, and for 21 we can write 3 into 7. Now we will try to find the common factor. We can see 3 is the common prime factor in their factorization. So HCF of these numbers is 3. Now to find LCM, as I explained earlier, we will write all prime numbers. Which prime numbers are appearing here? 2 is coming, 3 is coming, 5 is coming, and 7 is there. And we need to mention their highest power. Now 2 is appearing maximum 2 times here. 3 is appearing only 1 time in each case, and 5 and 7 are also appearing 1 time. So 2 power we will write 2, while for other numbers we will keep their power 1. On multiplying all this, we will get LCM, that is 420. So this is how we can find LCM and HCF of 3 numbers also when it is being asked. Now another question. In this we are given HCF of 2 numbers. In bracket they have mentioned the 2 numbers 306 and 657. Their HCF is 9 and we have to find their LCM. Now when we are given 2 numbers and their HCF is also given and LCM they are asking us to find. Sometimes they may give LCM and they may ask us to find HCF. Then we will not start solving by prime factorization method. We can apply the formula which we have learned, that LCM into HCF equals to product of 2 numbers. Since we are knowing one of the terms from LCM and HCF, if we know one thing, we can definitely find other thing by using this formula. Now in this case we don't know LCM, so we'll keep it same. HCF is given to us, that is 9, so we can put its value 9, equals to product of 2 numbers. We know the 2 numbers are the numbers which are written inside the brackets, 306 and 657. So we can write them like this. Now to find LCM, we will simplify this equation. This is a simple equation, we have to simplify. This 9 is multiplying on the left side. When we take it to the right side, it will get divided. So we'll get 306 into 657 upon 9. Now we'll just simplify it. We can cancel, we can reduce on 9's table. This will get divided by 9 and we will get 9 3s are 27 and 9 4s are 36. So we will get 34 here. So we are left with 34 into 657. On multiplying these 2 numbers, we will be getting the answer, that is the LCM of these 2 numbers. So on multiplying it, we will get 22,338. So 22338 is the LCM of these 2 numbers. This is the required number. So that's all for today. So we learned how we can find LCM, HCF, prime factorization and solve sums based on it. Hope you understood. Any doubts, feel free to ask. Thank you for watching.